May I now invite Mr. Shri Raajkhaanth, founder and CEO of Vector Consultancy, to the stage for the presentation, please.
Good afternoon, ladies and gentlemen, boys and girls, and young engineers. Welcome you all to National Career and Productivity Fair 2019. And our sincere thanks to Mr. Jancha and our partner CGTI for inviting us to present the case of embarking journey on Industry 4.0. So this afternoon, we're going to discuss about what is an Industry 4.0 and how an organization should start the journey towards Industry 4.0. It's going to be our presentation objective. Okay, I represent Vector Consultancy, a consulting organization located in southern part of India. A small introduction about us and the services what we offer. Basically, Vector, we focus on improving process and people. So what is an Industry 4.0 is all about? Okay, a small introduction. Okay, in 1784, the first industrial revolution started. Mechanical machines were used for manufacturing, and these machines were driven with steam and water. So that's the first revolution, using of machines for manufacturing, which is called Industry 1.0. Later on 1870s, the machines which were used, operated by water and steam, were used to operate with electrical energy. So electrical energy was introduced in the process of manufacturing. That's the Industry 2.0. In 1969, the industry has gone into the third revolution, where the processes were automated. So that's the majority of the processes were automated. That's Industry 3.0. The fourth industrial revolution is happening in this era, where the focus is more on responsive intelligence and cyber physical system. Okay, physical presence and digital presence. We are in a process of linking this. This revolution of linking the physical system to the digital system is called Industry 4.0. Okay, so to understand what is not Industry 4.0 is not only just an automation, but and also it's not just a speed of execution. It's all about a responsive intelligence, looking at the system, looking at the situation, the machines responds according to the necessary. So that's Industry 4.0. And a big shift from labor intensive to capital intensive. The process of moving from labor intensive industry such as apparel and footwear industry to a capital intensive industry is called Industry 4.0. So Industry 4.0, people always look at the smart factory. So what are the factories, how a factory will look like? So how a factory can grow. A small introduction video about a smart factory. So just an introduction about how a smart factory look like. Okay, and we've seen a lot of apparel and footwear industry currently operating, and the migration path is what we're going to talk about it. Okay, the future factory, what are the things which we can expect in a future factory? Okay, automated in plant logistics and warehouse management. We most likely to see an automated warehouse where the logistics is completely taken care by the intelligent systems. We're going to talk about the data collections across the supply chain. So wherever the data is available or needs to be generated, it is generated at the point of use and sent it to Internet of Things for big data analysis and decision making. Predictive maintenance, data-driven predictive maintenance, looking at the machine performance and when this periodical maintenance to be taken. So these will be available in the future factory. Right? And hand in hand, harmony with human and automation or robotics. A lot of things in the upcoming styles we're going to talk about how the industry currently looking at the human interference with the robotic systems. Digital quality systems and advanced SPC, statistical process control. So the quality control systems is no longer is going to be a people judgment. It's going to be from digital quality systems and statistical process control. The system is going to tell us whether the produced products are of right quality. And digital performance management systems where the human performance is measured digitally as and when the transaction happens. So that's the expectations or whatever is going to be in the future factory. So embarking on Industry 4.0, how do we do that? From the current situation, we want to move to Industry 4.0. So what is that we need to do with? Okay, we grossly classify the current processes into two. One is the physical processes, the second one is a non-physical process. What is the physical process? The physical process is, what are the steps for the physical process? Okay, one is the process automation. Okay, we may have several processes in the industry. So we'll first do the process automation, which is actually Industry 3.0. And then create connectivity. So can I create a connectivity between one machine to another machine? So actually your 4.0 begins here. Okay, and parts and product automation. So small parts and small product automations happens here. And then give those informations to Internet of Things. So therefore the data analysis is available. And finally bring the flexibility to the systems. So these are the parts for a physical system. And non-physical processes, we may have a digitalized the manual information. Whatever the informations we record manually now today might be recorded digitally, and later on it will be converted into automatically. Based on this, today digitalize the decision making and automate the decision making are going to be the milestones of non-physical processes. Now we're going to talk about what are the systems which is available in the apparel industry and the footwear industry for the process automation, and how do we create the connectivity between them. There are a couple of videos for us to understand and derive our roadmap for our Industry 4.0. Okay? So the process automation manufacturing. Okay, so one of the automations where you can see the elimination of the skills and consistency of the quality. You're going to come back, you look at it. See, all the top stitches or any one of the single stitches can be completely automated with the human skills, and not only a straight line, and curve lines also can be done. Okay? And it's one of the so far it was very difficult to do. Straight curve line were very difficult to do it, and industry has come up with the process automation with a different curving nature. It completely eliminates the human skill and the training which is required to do the human skills, and gives a product quality consistently and productivity. Right? A small process automations, that's the first step which we talked about, the journey of Industry 4.0. Okay? Few more. Where are the processes? It only can be done in the sewing? Not necessarily. Okay? All your non-value added activity or lean based non-value added activity can also be automated, and therefore you can eliminate those non-value added or automate, or cost of manufacturing can go down significantly. All the marking processes can also be automated. At the gross level, you will have around 5 to 6% of the people who is doing non-value added activity. This can also be significantly reduced. right? And the template-based automation. Okay, the next step is, all the template-based automation can lead us to Industry 4.0 because these are the processes which helps us to run without a skill and without a human intervention. Today's template-based manufacturing helps us to de-skill, bring a consistent quality, and also the skill level required is only to pick and place. In the later part of the stage, it can be automated with pick and place robotic systems. The only skill which is required to run the process is pick and place, which can be imparted with a very less hours of training and as well as a skill. Okay, not only the shirt manufacturing, the majority of the preparatory process of many of the apparel manufacturing can be done with this template-based manufacturing. Okay, a lot of things which you are seeing right now in the video has been skill-based processes in the past, and it's no longer is going to be a skill-based processes. It's going to be completely machine-related processes. This also helps us to predict the output accurately and the efficiencies of the factory and processes remains consistently. Even the simple processes can be template based so that anybody who is new to the industry can accommodate to these changes and do it. And it's a flexible system, so therefore, unlike earlier templates where you need to spend a lot of money on creating a template which has come up very, very cost effective way. Right? So those are some of the examples of template-based automations. A lot of joining processes, a lot of top stitch processes, attach processes in apparel industry can be converted into template-based system, which eventually will reduce the manufacturing cost and creative competitiveness in that. Sorry. Okay. For a non-manufacturing, we've talked about the process automation in the manufacturing, and non-manufacturing, what are the things which can be done? Okay, automated warehouse. A lot of storage solution can now be automated. You can see, and future is going to be there in automating warehouse system. support system, again, these systems are designed towards Industry 4.0. The system decides based on the marker and spreading necessity and picks up the requested fabric and brings it to the cutting table. It actually, wherever the possible, it gives you an opportunity to store vertically up to 30 meters height, where the space is inexpensive. These systems comes to hand in hand to reduce the manufacturing cost. Right? Okay. And the other important is the material movement. Okay. Majority of the apparel factories, the material movement becomes a challenge. We normally ask people, whoever is running the apparel business, we normally ask them to go back to your payroll and ask them to put each one of them, how many of them are your material movement. People who is moving material from one place to another place, just put their salaries. You'll come to know how much is the money an organization is spending to move the material from one place to another place. In our study, it says roughly about 5% of the labor cost is dedicated for material movement. Just moving material from fabric warehouse to cutting room to sewing room to finishing and packing. There's a lot of money which is involved in there. A small automation, process automation such as this can help it to overcome those costs. Very, very cost-effective solutions, and tomorrow it can give you as a result, and very inexpensive thanks to the technology of material movement. A milk run, a lean manufacturing milk run concepts, just moving from one place to another place on the designated path, like a bus station or like a metro, so wherever needed, offload it and unload it, and the manpower cost associated to this is majorly reduced. And it's much cost effective than any one of the conveyor systems or hanger systems which today is available on an unaffordable way. And this is a very much affordable. Any one of the small enterprises also can implant this. And you can design the movements wherever you want it to go with the magnetic strips. That's it. It's about 5% of your operating expenses can be reduced through these systems. Right? So that's about small automations in the non-manufacturing processes. So far we have seen through a digital system. So actually a robot or the machine signals are passed to one to another, where to start, when to start, and where to stop and when to stop. It's an excellent model for connecting physical system to the cyber system. Not only the same machines, if you look at this, there are also multiple different machines can be connected for different processes. Let's have a look at it. There are two panels picked up. On the white side glasses, these fabrics were inspected with the image processing techniques, moved to the overlock machine to do the surging process. And processed panel is placed on the other panel and moved to a single little machine, two different machines. And the machine response is an actually responsive intelligence, responds to the motion and start doing an overlock, single little top stitch process. By doing this, two panels have been attached together. Okay, pick and place robotic system, picks it up and move it for dispatch. So as an operator, we only need to load those required machines. This also checks the quality control and carry out all these processes. Again, an excellent example of connecting to physical system through cyber system becomes cyber physical system. Right? Series of process connected. Again, it's an excellent example. If any one of you are into shirt manufacturing, possibly you will see an excellent connectivity which happens. 4 to 5 different processes are connected, not only a sewing process. We can have a look at it. So the pressing of the cuff happens. It's moved for the top stitching as soon as the pressing happens. The machines, because of the responsive intelligence, process this and moves to the robot. The robot picks up this cuff and send it for buttonhole attach. So four different processes are interconnected, and we finally get the part output or semi-product output. So all those processes are possible. Okay, not only apparel industry, shoeing, again, it's a responsive intelligence. Okay, it need not to be. Earlier automation need to be on a consistently and mass productively. If you look at the gluing process of a shoe, you will see the orientation of the sole are not same in the two consecutive. And still the machine predicts this and apply the glue accordingly. Do different shapes, do different orientation. The responsive intelligence helps to glue them on the right surface. Right? So the upper automation again for the for the apparel we've seen several processes of automation. Let's look at the shoe manufacturing. Okay, again a robot assisted template based loading. The reason we said the template based manufacturing is the first step. As soon as we have a template based manufacturing, we can use robotics to load and unload. A complete upper of different parts are stored, are manufactured with this template based manufacturing. So that's the outcome of the upper. right? The milestones are process automation with or without the template sewing. Okay, if you are from the manufacturing background, okay, look at each one of your processes and see the possibility of template-based sewing or process automation. Do that, and we can, as soon as we are done, we can enable the pick-and-place robotic system, which can help us to connect two physical systems through cyber-physical system, wherein IoT is enabled, as simple as an Industry 4.0 embarkation towards this. All right? So non-physical process, data capturing and analysis. What are the things today this world is available? Okay? The connected system. What a traditional quality controller does, this measure this measurement and keep on writing it in a piece of paper. No more. The technology has given us an app-based solution that you keep measuring it, it keeps recording it, and also immediately the artificial intelligence tells you the measured products are of right quality or inferior quality. That's on the cyber physical system, on non-manufacturing processes or data processes. Right? Digitalization in maintenance. Okay? One of the majorly ignored areas of today's apparel manufacturing is maintenance of completely fingertip informations, digital process when the machine, what is the uptime of this machine, and when it needs to go for a periodic maintenance are available with the digitalization in maintenance. These are necessary as an organization migrates from Industry 3.0 or 2.0 to 4.0. These are mandatory to monitor it. Right? Shirt manufacturing, to sum it up, the shirt manufacturing, what is that? It is given as a 4.0. It's a 45 to 50 people from cutting to packing with an average salary of $250 per month, can produce 2,000 shirts per day in 2 different shifts with an investment of $700,000 with an ROI of 14 months. Now, that's the outcome of Industry 4.0 in shirt manufacturing. Right? Business intelligence investment, where if you are a business owner, where you would like to do the intelligent investment. Okay, 79% of the investment is expected to go with the cameras and videos, and loss prevention and inventory visibility elements enabled by operational technology, software analytics and loss prevention, big data solutions, predictive analysis, again cameras and videos analytics for customer experience besides the operational purpose, and visual analytics for making sense out of the IoT data, and finally cognitive computing to drive optimizations and insights. So these are the areas where the business is expected to invest in the upcoming future. Right? Camera-based inventory systems. Today, these are operational in the stores. If somebody comes and picks it up the shirts, who is picking it up, what is the age, gender, and when it is picked up, and what quantity is picked up are available at the point of pickup. All right? So finally, whatever we do on the processes, a small video which always makes us a fun is how do we connect the processes with the people. Okay, that's a very important thing for any of the businesses to be very successful. Okay, a process automation is not going to be successful unless we manage them, we train them right. Right. So, any process automations or any migration without taking people along with us will lead us to a chaos and not yielding the desired results. So what is the kind of a setup and structure we should have an organization when we want to migrate to a Industry 4.0? Okay, a technical team, a strong technical team to confirm the quality. A strong engineering team consists of both mechanical and electronics discipline to be in place in the part of a team, and an IT team. All three needs to be collaboratively working, and a new setup of department called automation department to be established as a basic necessity for moving towards an Industry 4.0. A few years earlier, every one of the apparel industry was busy in installing industrial engineering department a few decades, and this is the time anybody is looking for the future should install this department. And what is the kind of skill sets required in this department? The people skills required are complex problem solving. The problem solving needs to be people need to be motivated to solve the complex problems, not resisting towards the change. Second, critical thinking, thinking ahead and thinking radical are going to be the qualifications of this team. Third, creativity. Okay? Out of the box, a lot of things which is available today were never been thought in the earlier days. It's going to be available to us. Is all because of the creativity thinking. Now, people management. Okay, how do we train the people and how do we manage the people in the new environment? Because labor intensive to capital intensive, we need a lot of engineers to manage the machines. So hence, people to manage those people managing the machines are vital role. Emotional intelligence. How do we align our emotional thinking to achieve the goal? Right. So that's about Industry 4.0. Begin your Industry 4.0 journey together with us, and we are a consulting partner with CGTI. If you have any queries, you may approach us for your Industry 4.0 journey. Thank you very much for giving us an opportunity to present the case, and once again, thank you for all.